Alright, so we're gonna start the TO2 class, right? And we want to talk about final project a little bit, then let me create an announcement and send you a sample final project code and expectation. Then you have it early, then you have an idea, right? Since we have question about final project. All right, so everybody know how to use Git? Who said I do not? So everybody know how to use Git? Git. Yeah, GitHub. Like that. Git. Yeah. So you find a test summary report, huh? F4 with my droplet integrate test script. Yeah, you have to do the test too. We talk about that. You have to do use Marathon to test your application. Like unit tests just test the modules in your code, right? So Marathon will test the actual application running, like just simulate the test. The test automation for JavaFX application. It's pretty much just simulating like the action that you do, like yeah, include the test runner UX. Like when you do tests, when you run application, you pretty much just gonna have to sign in every time, right? Sign up, log in, right? And then you test another account, you do the same. Now when you make changes in your code, you want to test again. It could be time consuming. You can actually record it, record the action that you do. It's just like you record all the simulated that you test, fill in, type in. And then next time you just run play, it's going to run it for you. It's going to go into the application, launch it, put in information that you need, and test for you. When it say errors, see errors, it just show the errors. That makes sense? Then you don't have to do keep sign up manually every time. Okay. So we can start to pretty much just look at Marathon, just download it and try to play around with it. Downloads. Right? You can have a trial version, latest version. Okay. Now, yeah, it's gonna be runnable file, so we'll talk about that, how to make a runnable file, right? And he also created a web application. And this is like I said, this is pretty much just going to locate the restaurant in the area from your location. And he integrated with Google Map and get the direction to the restaurant. And then you can purchase the gift cards. So this one use Google API, JavaFX, And then we will talk about heap, graph, and index list. Heap pretty much just use index list for the login. Okay, user login. Right, you're still in early stage, but this is pretty much a final product. Okay. So what you can do, you can always clone or download it from there. And then you can run the program and test with that. Check out form version control. And clone. And then it pretty much give you the structure of the whole project already. Now you start to learn from there too. And then start to modify and make it, right? Create on your own, right? I need to find a location. Change the location. All right. Now, so I'm going to let it clone first, and we'll come back and look at that. Okay. Yeah, it's pretty much clone here. It's still in the process. Yes. All right. So this is pretty much just the whole project structure here. So we have the controller, these structures. These are all the structured folders, right? Like form, queue, stacks. Those are things that we learned, right? Use linked list to create a stack, right? These are just the object class, right? Person. Like user, right? When we implement, pretty much just things that we learn, right? Extends username, email when you sign up, right? This is just authentication, login. Pretty much, you already have all the guideline from project 1, A1, right? and then you can start to see A2. A2 pretty much just focusing on implementing this structure here. You're probably going to have less because I didn't require you to implement everything, but before I require to implement everything. Right, this one I didn't ask you to do. Like this one I require to implement all of them. Okay. Unless you want to do more, which is fine. You can talk about that. And this is logged in. And let's see. Here's the fxml, right? This is where you have to start the fxml, right? You start a program from here, right? Main. Let's see if we can run it. All right. Let's see if we can see what the username and password is. It should be so if you create a text file or the object file, it should be, yeah, object file is not going to be able to read, right? Yeah, and then you have to do the report like this. I have the guide library reports, so pretty much combining with introduction of the program. And then this is pretty much just have the documentations. And then you're going to do summarize the test result, like fail, pass. And then the JUnit test summary for each of the methods or classes. And then, yeah, this is just a JUnit test result, right? And recommendations. All right, so this is you write a code, you test the code, you create the reports too. And this pretty much is the version revision history of the documents. All right, so now let's see what is the password, right? Username. So it seems like this is serializable. This is an object that will write to the file, right? So we have to find, because he's pretty much stored this user into the structure, correct? So Let's see. Sign up, right? I'm looking for sign up, new account. So that's a new account for the fxml. It should call the methods, right? So when he hit the button to sign up, register. So register should call the, look at the code. So let's look at register in the code. Create account, right? So the method name create account, that's the action. So create account. Now we want to see who's the controller. New account controller. Under the package controller. So that's pretty much how you trace back the code, right? So we want to see the method create account right there. Right, so this is just validation that you have done on assignment 1, A1, right? New account, get text, right? Under U. Okay. So after we have this, what's next? Add a new user to index list, right? So he used index list, right? So this is pretty much just your A2 here, right? You modify your A1, right? Now you create your own. So he had it under, he pretty much just create under, this is his own code, account data tracker. He just named that file output index account. He create index list and he implement his own index list and add the user to index list. And then this is pretty much the file that he wrote the object when he read back. So this is the file here, accounts index.dat. Write the object. When you close application, it's stored there, then you could pretty much just pull the data back, right? So let's create a new account then. Username CSC 202. Password.
So for the project, do you want to make as fancy as possible for the background and stuff like that?
No.
Is that like optional?
I think that's
Or is that, like,
10% like the design and user. I think if you look at the grading rubrics, we have some grade for that. The design, user. I mean, if you do like very bad design, then you don't get the credit for that 10%. It's not required to have the fancy looking, no. So this is just.
But they're like videos on how to do that. Like if we have book on how to make it fancy, or is it just something that we have to watch?
Okay. Oh, there's a video how to do it? Yes, yes. What's the requirement? At least one number, one uppercase letter. Okay. One lowercase letter and one special characters, huh? One. And what's the length? Is that limit on the length too?
They didn't give us a link.
No.
No, you aim it.
So number, uppercase letter,
Lowercase s.
lowercase, special characters. I'm not sure if that length limit. Let me make sure I have enough then. Alright, so number, uppercase letter, lowercase letter. Okay. So this pretty much just the one that you already know. You've done that. CSC. Number, case letter. Okay. There's an errors now. About a picture, huh? No further exception.
You think because when he did for the picture, it only allows him to pick the picture from his computer, and you can't pick a picture unless it's on like that specific computer. Is that probably why?
So it's something with a picture problem here, huh? Oh, this one also. I need to provide the Excel file, huh? OLE2 documents. Index outbound. This is a picture and all right. So I think I'm not gonna spend time to look through this error yet. Then, but at least now. Oh, he hard coded the 0. Yeah, this is not a good way to do, right? When you hard coded this. First, I have to even see if we have that Excel file that he referring to first. Yeah, this is pretty much it's gonna come up in A3. Okay, so that's why it's kind of a little bit early, but you start to see it. You have to get the data, and this one pretty much the data of the restaurant pretty much is stored into the Excel file. Okay, and then read that information and load them into the table. And we're gonna do the table view here. Yeah, we're gonna talk about that more. So now let's look at we talk about Excel file, right? Let me just show you that. View. So we have So this is the one that we're talking about. So we have the list of all the restaurants. See that? And this is pretty much created from the student.
So we're
like
create
you.
our own hostel, or is it like we just look
This
at the hostel?
this is going to be shared. Like now, you probably want to do. I'm going to pretty much use both because we have both. So I'm going to share this to. I have your email, so I'm going to share this to you. Then you have an access to the list. So what I'm looking for actually. Anyone know how to write an API? Like an API services? Like, actually, let's talk about that a little bit. Google API. You guys heard about Google API? No? Who said no?
API is like the map thing. It's like you make your own map.
It's not just that, right? It's one thing is map, but there are more. Like for example, this is a list of APIs, right? Contains doesn't methods. It's just like when you create your own data structure, you can make an API of your data structure, right? Like Java collections have an API to do like uh, map set, right? That we learned last time, right? So you technically can make your own code to be an API too. Then people can use, right? You can package, make a library for that. So these are, for example, yeah, if you want to get the data from blockers, you can get this API. If you want to get like Facebook has Facebook API, right? Yeah. So if you want to get the data from Facebook, you probably want to use Facebook API to get the data from Facebook. Application Program Interface. So like this is Facebook API for the Graph API to read and write to the Facebook social graph. Like you can write a program to write to Facebook social graph. I don't know what's Facebook social graph. You guys know? You don't use Facebook?
Everything.
Oh, I see. This is good. This is using graphs. So this is a technique of that we're going to cover the topic of graph. Maybe we should handle this application. Let's do script Facebook API then. So like we're gonna talk about graph. Okay, graph is pretty much one like we talk about list, set, map, tree, and then graph, right? Graph is another type of data structure. So if you look at like each node, right? We talk about Linked list, remember, right? So this could be a node, right? And then you point to the next node, right? A graph pretty much just you can connect between the nodes, just like a graph like that. And the way, like, each node is an object. This is a user object. Facebook make it as a user object, right? And the link between the user object could be friends. That's why when they recommend friends with you, they just use the graph to search the list for recommending the friends. Maybe we want to do that for this time. Make sense? Let's say I'm still thinking like last time they do hospital, last time they do restaurant, right? This time for the project you could do, you create a node, right? This is a node for the user. And then user is related to this user. It could be friends. It could be siblings, right? Cousins. That's why they have, at the end of the day, they are connected together. Everybody in the world pretty much connected. That makes sense? That's how we make Facebook. You see that? Because people know each other and you know somebody else, I know you, right? At the end of it, all of them connected. So that's why when you go, we can make something like this as a like to learn about how graph works. And then you can start to make a list of recommended friends on your application after you sign in. Like you sign in, you have your profile, and then you have a list of recommended based on the graph they structure. But then you can do I add friend, then it start to recommend it more friends because that friend has more friends, right? It's always like that, right? In your social network, right? Yeah, let's look at that. So that means if you want to use API, you can use the Graph API here from Facebook. Okay. All right, so this is just an example. Like last time, they pretty much just used Google API because they're talking about map. They want to find location on the map. They use Google API. And then they use Graph to find like locations, like the location where you are, and then suggested nearby, like restaurant, recommended the restaurant. Make sense? So let's do this. This time, actually, I want to do this one. It's gonna be very interesting. I want you to do application. So now you get authentication in, right? The A3 is you can start to talk about you creating. You already have user create account. So after you create account, this become a new node, right? Whenever you create a new account, you have a new node every time. So now we have to link people. So that's why you have to change as you create account a little bit by start to remember then when you create Facebook account, they ask you to add friends. Hmm? No, we didn't do hospital. Like I said, that one I'm gonna adjust it a little bit because you on the phase of login, right? Now this one we gotta do people. Okay. Yeah, I'll write up the description in more details. So now you're going to add the friends, right? you start to add friends. So you have to have the list of friends, right? And then you can pick the friend that you add. But we're gonna add based on this criterias. Okay. Based on their like. You're gonna have a list of friends that like the same thing. You're gonna add them together. Make sense? So like the graph here that we see, they should have the conditions, right? Like how they can link together like that. Like, cook, watch, friend, listen. See that? So we go link based on their like. And now we gonna search, like for example, if I like General Shao, it's gonna show all the network that like General Shao. Make sense? Because we use this structure, remember, we can search the key is General Shao. And then it's gonna go into the graph and return result very fast back based on efficiency. Make sense? So that's what we want to do. Okay? That's the whole application after you sign in. All right? I'm going to write up the description and post the update on A3 and 4, and then you have an idea. Okay? Now you have an idea what we want to do. All right, so now we come back to like this application. Like I said, there's some errors. I don't want to spend time fixing this. Okay, but we're gonna talk about that later on. But you could use this base to start to base on your assignment projects. Okay, then you see how we structure it, and then when I have time, I'll show you back after I can fix the errors first.
So Professor, I have a quick question about the midterm. What would you suggest us to do to like study for it? Because we can't exactly just um practice. Like what would you suggest to do?
Let me try to find our. I thought I opened that document. The midterm. When is it?
It's I think November something.
Is it the end of October or November 1st?
Is it second? I don't remember.
Hmm. You can check the syllabus. Yeah. So I think it should be either by the end of this month or
I think
beginning of
it's
next month.
November 2nd.
Yeah, beginning of November, right? It depends on the day. So what's the question about it?
So I was like wondering like how do we exactly study for it? What will be on the midterm drive? Because like is it online test midterm?
Yes.
What
So midterm is November 1st, like I said.
so will be like multiple choice
So it's gonna be on your
platform?
on Wednesday. Yeah, multiple choice blackboard, yes.
So do we
Fill in
have
the
to
blank, multiple choice, something like that.
so will we like come to class and take it? Or can we take it out?
You come to class and take it.
Okay.
Which book would you want us to study from? Is it gonna come from the book or
from
on
the
Jordan?
required textbook that you want to study from?
Which required textbook? The one that originally required for this, or the one
The
that
edition 4.
edition?
So the one we don't do
The one that
We had to
when
take
you
it.
have to, we don't have enough, then you go to that one. It's the same topic, I'm telling you.
But no, I'm saying we've been doing our homework out of one book, and we've been reading that book. But now you're saying the test is coming from a whole different book.
You can study from both. It's the same topic.
But-
It's the same thing.
But what if it's not? I've actually read through the chapters they don't line up.
Yeah, some stuff.
They don't line up, but at the end of the day, it's the same thing. It's the same thing to search
Could
to.
you give us some examples of
A study guide?
Yeah,
that's
you
it.
can set a study guide,
Could we ever study class? Like in class we would just study?
or like a study guide would be fine too. We go
I
through
think we have it, right?
Something, I'm trying to go in blind.
You all want here to get an A in this class, so.
Course documents.
I think we should make a really, really good
You
study
see,
guide.
you made the final test study guide, so therefore can you may you please make a midterm study guide
How about we do the videos for study guide?
video?
No, I want to be able to stay at home and
I mean,
something
you
to look at.
Oh, okay. I'm going to show you from my record if you want to, but it's fine if you don't want. Hmm?
Oh yeah, open notes.
Open notes.
Like you had to
Bring a
write
study
everything
guide.
on like a 3x5.
Can we like a cheat sheet?
Yeah, like you had to bring one
Maybe
sheet
by
of paper
ourselves.
and
I
that's
don't really know what to
it.
write on it.
Like 3.5.
No, like it's not how you
Right.
that tea about the guy about like no, like
I guess so you're seeing the study guide, but I think it's not good enough. That's what you say. Okay. Then I'll make a better study guide, right?
That's your homework for the week. No, that's
Wait,
the
we get to write
professor's
that test?
homework.
That's our
Professor.
homework?
Hmm?
Professor.
What's that?
He said that's the homework for the week, right?
Your
You lecture.
homework.
Not
Is to
ours.
make a study guide.
Hmm.
Yeah, just let me write that.
And it's gonna be graded too. No, I'm just messing with you.
All right. So yeah, I think we just see only one of the course documents, right? It just cover the topic, right? Link list, array, thread. Okay. Yeah, we gotta make a better study guide. Okay.
It's due one day at midnight.
All right. So I mean, all the let me see. All the question that you should expect is pretty much like you have to know how to implement. Like, if I ask you to implement the pop stack, do you think you can do that? Use array?
What do you mean by implementing? Write the code from college?
Yeah, the whole thing. Like that. Like, if I want you to do like index list, I want you to implement get like that, the whole thing. Like the code, the test is pretty much just have you blank and you have to fill in that for each operations. And we have stack, queue, unordered list, linked list. So that's why probably if you do A2 with all of them, you probably prepare for your test already. Okay. which we actually about to cover it too in the following section in chapter what 20. We are in 23, right? In 24 show how to implementing it, and also you have to know all efficiencies after you implement. Like if I asked you what's the efficiency of pop stack, you should tell me right away.
What's it used?
What's efficiencies? We talk about efficiency, right? We've been talking about efficiency, big O, right? Of the pop, yeah. What is it?
Is it just N? It's N.
Why is it N? Why is it 1? If you know how to implement it, then you know right away. Okay, why is it N? How did you pop?
No, I guess it might be one.
Okay, why you say 1?
There's
There's
no
no
brain. One action.
There's no iteration.
No time.
Okay, now if we use linked stack, right? If you look at linked stack pop, it just check if if the list not empty, you just returns what? You actually pop this one doesn't have to return, but you just this is using array look like. Yeah, this is an array, right? You put a node to that location. So that should be 1. Efficiency is 1, right? Like you should know how to implement this thing, and you should know what is efficiency of it for all of them. Stack, queue, unordered list, order list, index list, all the operations. Okay, like we gonna talk about more. Okay.
You're still gonna make a study guide. Alright. That's how I do best in class, before test.
I guess if you technically review this video, that's part of it. This video that we're recording, streaming is part of it, but we do it again. We gonna have the study review before the test. Okay, the week before, right? Yeah, and then we have to do it together too, to review, to make sure that you get an A, right? Make sense? But at least now you know that you should know all the implementation. That's why A2 is to actually give you a chance to implement all of them. And pick one that you want to use. All right. Now, we were looking at efficiency, right? 22 already. We were talking about sort last time. Any question on this two chapter 22, 23?
I don't think we finished. When we got to a certain part.
Yeah, we had heap, and we said how to measure that, right? How do we get the efficiency of the heap sort? It depends on the algorithm you implement the heap, right? So let's see, how do you implement the heap? This is heap, right? So we said we create a heap class. So this is a UML diagram, and the heap pretty much just has a list. And is it an array list? So these are the operation: add, remove. See that if I ask you what is efficiency of heap add, then you should know right away on the test. If I ask you to implement heap add, you should know how to implement right away. If you're good with that, then the test should be fine for you. So that means you should start writing the code. Okay. So let's look at when we add, we said we going to create, we already created the list right in here, right? As an attribute of the heap. So the question could be, what is the efficiency of the heap constructor? So if we talk about this heap constructor is initialize the objects, right, of the array, and you keep adding objects. So this is when you're creating it, you call heap to create a heap, and then you create an array of objects, and then you loop through it into the length. So this should be an n because the length of, right? So efficiency of the heap should be n for this case. Heap constructor. Now these are pretty much just we have to look at what is an array object here that we're passing in, right? So it depends on that. But this one we said add. When we add, we pretty much just add the new object, right, to the heap. So when we add, remember what's the heap rules again? What's the property of the heap? Shape and ordered. So we said parents always higher than the children, right? So when we add the new object, how do you know that the parent is higher than the children? But we don't know if the new object is going to be lower or higher because it's in order, right? The number is not in order. It's unordered, right? Like 5, 3, 6, 1. So the object could be 5. The first one is 5. So 5 is the root, right? Now I add 3. We know 3 has a shift on the left. It's no longer a root. But now I have 6. 6 should be a root. We have to move 5 down because 6 is higher than 5. Remember that concept, right? That's a heap. So we try to implement that. How, right? How do we know that? So we said, okay, we append the object to the list because use array list here. And then we start to say, okay, we check the index, right, of the last node. We get a size -1, we get an index. Now, while the index greater than 0, all right, so let's look at the image again, right? Heap simulator, right? So I'm gonna get the list again. So let me I'm going to create the list 5, 1, 3, 6. Okay. So I'm going to add 5. That's going to be a root. Now I'm going to add 1. How do we know that it has to go in that location, not replacing the root, right? So let's look at the code. First is try to get a parent index. All right, let's talk about array a little bit. So let's create an array. So an array, when I create, I have first object, which is 5. Where would the 5 go? When I add 5, it adds to the list. So when I do that, this is an array list. When you append, it's going to append according to what? The order, right? So array, let's say array. Array has index 0, 1, 2, and so on, right? So I put 5, 5 will go there, correct? This is array list, right? When you add, it's add to the first index, right? And actually, I'm going to add, where add 5 is check list dot size. In this case, it's going to be 1, right? 1 minus 1 return current index is 0. There you go. Okay. So we take a note that already that's current index. But let's say I want to add 1. The current index is going to be 1. But I want to see who is the parent. What is the index of my parent? So we said current index 1 minus 1 divided by 2, you get 0. So my parent is 5. Okay, so this is the algorithms for that. 2 returns the parent index. Alright, so let's try another one. So I'm going to add, what's another number? Alright, 3, right? Let's add 3 to the list. So insert 3 to the heap. So what is the parent index of 3? That could be on the test too. This since you're asking a test, this I remember maybe that was on the test. The formula to get the parent index, how do you do that? So this is it. This is a formula to get the parent index, right? So I add 3. 3 should be here. Remember the index is going to be current index is 2. 2 minus 1 is 1. 1 divided by 2 in Java we get 0. The parent index is 0. So 5 is my parent. That's how you implement a heap, right? With an array. So if list.get current index, we have to compare. Like it's not always going to be correct because if the order is higher, right? Because we want to make sure the heap property is complete. So we have to compare list.get current index, meaning you get the values, right? Now the value is 3. My current is 3. I'm talking about current, right? Compared to list.get parent index. 3 compared to 5, correct? Who's bigger? When you do compare to, we said this compared to this, it's going to give you negative because 3 is smaller, right? It said if it's greater than 0, meaning that you have to change your parent. The parent has to be the new one that you add in, correct? And this is the algorithm to change. So just move the one from the current to temp. So let's try that with the next one because we're going to add 6, right? Else you technically don't do anything, you break out. Like 3 is less than 5, you break out. The 3 is the heap now, right? 5, 1, 3 is the heap. And we know why it's the heap because the shape is complete, parent greater than children. Now I'm adding 6. So if I insert 6, you see that where will it go first? It will go to 3, right? Index 3. Who is the parent index? Remember the formula? 3 minus 1 divided by 2. My parent index is going to be 1. When we do this, it's always going to put 6 underneath here. You agree, right? Because my parent index is 1, right? We do that because we want to keep the shape property. Make sense? So the shape is complete now, but the order is not complete. So that's why we have the else statement here, if statement here to compare, right? Now in this case, 6 is happen to be greater than 5. It's going to return 1. So 1 is greater than 0. Then it has to move 6 to the temp, and then you set the current index with the parent index is swap, right? It's going to move 1 here and move 6 there, correct? According to code here, right? And then, yeah, that one set the parent index to temp. All right, let's come back here and see. Insert. It's gonna move 6 there, but it's goes so fast. Move 1 down here, and then it has to repeat again to compare, because now the parent index is the root, right? It started to compare and say it has to swap. Now we have the heap back. So let's see how they do repeat again. While current index greater than 0. That's how they keep repeating and do that, right? To move that the second time, move 6 up. Right, because my current index at this point is not, let's see. Yeah, because it's say current index equals to a parent index, which is 1. It's still greater than 0. That's why it's swapped with 5. Make sense? So it moves 6 there. The third time is move 6 and put 5 down. And then now we have heap again. Let's say here and still greater than 0. Keep doing that. Now it happened to be parent index is 0. So no more loops. Exit. So that's how you do add. So what is efficiency of this code for add? And you see that when you do that, you're gonna get the, remember my list is not sorted, right? This is unsorted list. After I insert them, it gets sorted. Right. This is going to be descending order, but when you remove them, you can just make it in order, right? Like ascending order. So what's efficiency here? This is going to be log n. Because it's not completely go through the whole. Like sometimes it's just like when we add 1, 3, and 5. So it's pretty much just depending on the current index, which we're not going through the whole list, right?
How do you get a situation where it's n log n? Where it's O n log n.
This is the solution of a log n heap.
N log n or just log n?
Because when you remove, that's going to take you about n. So that's why it's n log n. Because you loop through the whole list, right? And this take about log n. So heap sort is causing you a login. That makes sense. You just ask situation. Like now let's look at sort big O. You have the cheat sheet here. So if you look at heap sort, right? Heap sort is about a login right there. We look at the worst case, big O. So our level only learn the worst case. The worst case, like I said, is n because if you do linear search, the worst case is the item that you search as at the last index, right? So in graduate level, you're gonna learn average search and best search. Okay. So the worst case, we only focus on worst case in this level. So these are the situations that you see in login. We talked about merge sort already last class. We talked about heap sort, right? Today we talk about bubble sort n square. We talk about insertion sort n square. We talk about selection sort n square. We talk about quick sort, right? What's quick sort? Oh, it's find a pivot. The worst case could be n square because if that list is in order, pivot is always going to be 1, 2, 3, 4, right? Remember we said worst case could be n square, the quick sort, right? It's normally it's get n log n, but if this list is already sorted, that's going to be n square. That's quick sort.
So the correct answer has to be n squared.
Yeah, for quick sort.
Isn't that
The slowest,
or
look at this graph, right?
it takes the longest, right?
The slowest is n factorial, right? This is exponential graph, right? Like, look that you have only a few elements. It take forever, right? The fastest is 1. Any number of elements, you get it right away in a short period of operations, which is time, right? So this is about a login that we see here. N square is still a lot. So whenever your program get into the RAID, it's called horrible. Okay, horrible when you write a program in the red zone right there. So try to stay away from nested, right? Nested loops. Always creating that. And log n still bad. N is fair. Log n is good. 1 is excellent. And Google search engine is about this, right? Okay, so now we have to think about how we're going to make our code to be the most efficient into good or excellent. Okay. When you search, you get the result right away. This one we not get the result right away. That's why we have map. Tree make things faster too, but still about login. About login right here. I mean, sometimes we can't. I mean, it still have to take time. That's why. Just like the whole thing is about organizing your data. Just like if you organize your house, your bedroom, you find things very fast. If it's unorganized, you couldn't find things. So that's why they have a crawler that try to get the data in and organize them, right? The web crawler. I mean, you don't want to use my code. That's based on my logic. But Google may have the best way. But I feel like they actually know you. They actually learn the user behaviors. Instead, like if you search something, they pretty much try to learn you that their algorithms, and then they try to return a result that relevant to what you like. That's why we link back to the social network, the node. You see that? That's why graphs come, right? So graph come, and then based on the node, it links you to another topic that related to you. That's why I want you to do the project related to that, right? You do graph, you have the node, and then you have the key. When you search for the one who love pizza, then it's just link you to all the pizza people, right? It's just like return a result right away, like search engine. Okay. All right, so this is just remove. Pretty much just go through the list, loop through the list, and now, of course, when you print out the list itself, you could get the left child and the right child index. And the left child index pretty much, if you start to look at this again, you have to look at, when you print, you have to go in order, right? Root, left child, and right child, and then the children of left child and the children of right child. That's going to give you an order. So that's why we have to get the index to print. And this is pretty much a formula to return the index of the left child based on your current index. For example, my index is 6, right? You multiply by 2, you get 0. So left child is index 1, which is correct. Right? If you look at this image one more time, right? That's 1. Right? And then the right child should be index 2. Let's go back. So this is going to be two times 0 plus 2. Index 2 is right child. See that? And then index 3, like for example, who's the parent of index 3? 5, right? So we're going to say 5 is going to be left. Index 3 left child is 5. Index of 5 is 1. 2 times 1 is 2. 2 plus 1 is 3. So left child of 5 is 1. Okay, so that's pretty much just showing you that that is true. It is 1 right here, right? So technically this formula just creating form is just multiplied by 2 because we start index from 0, right? And the left and right, just make it 2, right? Because binary search, binary right tree, only 2, and then you just do plus 1 for the left, plus 2 for the right. Same as a parent. To find a parent, it's pretty much just the same, you just divide it out by 2. And we start index as 0, so that's why you subtract 1. That makes sense? So that's how you create a formula. Now once you get that, you're pretty much just going to be able to find the maximum between 2 children. Left child index greater than or equal to list dot size, then we break. Why? So left child index is, like in this case, it's going to be, that means at the end, right? 3. If it's equal to the size or greater than, then we stop. and then it's return the left child index, which is the max index. Let me see, this is method to remove, right? So when you remove, first it's going to remove. By this method, you have to reconstruct your heap again. Because, let's see here, remove the root. So you have to reconstruct the heap into this shape again. So that's why whenever you implement, it's going to take about n, because you pretty much just have to do all of them every time. And this is just the algorithms how to do that. So you remove the root, and then you just check if it's a heap. If it's heap, then we don't have to do this. If not, it's pretty much just check the values, right? And then we do reheap again. Compare pretty much the same thing and set, just like what we've seen before. And the whole thing has to be in a loop. Let's repeat until it's worked. All right, so that's pretty much end of the heap sort. So we have bucket sort and radix sort. Yes. What we want to do, maybe we have to come back and look at this, okay? So this one combining two phases. So I guess you can, it's pretty much at the end of the chapter. So you can start to pick other questions and do your assignments for this week. And then we come back and we can go through, it's just a few more things that we want to look at, the bucket sort and radix sort, okay? All right.